Okay, we're ready to do 6A notes for the Math 4 course. And, sometimes it scares me the way that people throw around statistics in social media. And you swear that half the time they're just pulling it out of their butt, they aren't real statistics. I try as much as possible that when I see something that is statistics based, that I'm thinking about sharing on social media, I usually try and verify those numbers and see if there is somebody else who has the same numbers, or did this person just make it? So we're going to explore the world of the people who actually make them. A couple of goals that we're going to have for this. We're going to talk about the difference between categorical data and quantitative data. Quantitative is probably the easiest word because you think quantity. Those are numbers. That's the data that you're collecting numbers and that sort of thing. Categorical data is different because it's not a number, it's a thing. Stuff like if you were starting to record, you went around the classroom and said how many people have brown eyes and how many people have blue eyes. But, eye color is not a number. And so, it's a category. And so we have to kind of distinguish between these groups of data based on the kind of numbers we're playing. Now, we're also going to run into terms like discrete, continuous, nominal, and ordinal. We're going to come across those. As a matter of fact, we're going to start with a lot of vocabulary. And then over the course of the next couple of sections, we're going to keep tripping over these terms and seeing where they're actually being used in statistics. Now, one of the other things we're going to do is we're going to play with a new software called Kodak, which is really, really cool. The tail end of today's notes, we're going to look at a set of data about roller coasters. And they actually have 16 different data points about each roller coaster in the country. At least so this list, I'm trusting the list is fairly exhaustive. But anyway, somebody has collected all this data, and we're going to look at different ways of, you can't look at all 16 points at once. They've got, like for the roller coaster, they've got things like how old is it? What's the maximum speed? What is, and I can't think of it right off the top of my head. They've got those to play with. There's things like speed and age and what, is it made of steel or is it made of wood? That's the wooden roller. And so CODAP is a really cool way of having this kind of spreadsheet of all of these different data points and looking at them graphically. Now, we're also looking at being able to describe the data set by using descriptors like center and spread. And that will come back to, but those terms should sound vaguely familiar when we did standard deviation rather, in Math 3. Sometimes we would talk about the spread, how far out did the standard deviations spread out. Were they real close together at the mean, or did they spread out? That's a significant thing to look at. So we're going to play with that. Now, let's get into the terminology. Our first term is going to be a variable. Variable statistics is a characteristic of individuals in a population. They call different values. I would remind you that population and sample are two key terms here. Population, if I decided I want to find out what was the favorite ice cream flavor of all the students at Enlow, the entire student population would be population. Population represents everybody that you are looking at. And a sample is just some cluster, some group out of that. Like if I went to the 1200 hall and, did a survey on favorite ice cream, it would be a sample out of the whole population. We're refreshing our memory on terms of Math Now, the first thing that we're going to look at is, it's not categorical, it is qualitative. Not to be confused with quantitative. Remember, quantity. This is not quantity. This is qualitative variables. Quality says, how would you list all of the jersey numbers of a football team and expect to average? What is the average of the jersey numbers going to tell you? Not a thing. What if I looked at all the zip codes in Wayne County? We decided to average those zip codes. That's not going to tell you anything. So qualitative variables are things more so than they are numbers. Categories, if you will. Now, this next group of three, I would even do this with the three of them because all three of them fall under the umbrella of qualitative variables. All right. First group is categorical variables, also called nominal variables, where you've got two or more categories. Like I said, eye color. You've got brown eyes, blue eyes, green eyes. You got two or more categories, but there's no order to them. It's not like there's a first, second, and third place. Not a high, medium, or low to it. They just are, and they're in no particular order. Now the next group is the ones that there is a sense of order to them. High, medium, and low. Variables like, what was the qualifying speed of NASCAR race cars in a heat in a given race? They're all racing for the best time to have the best position on the pole. There's definitely a sense of first, second, and third place. There's a sense of order. Then, order is the appropriate word here. Now, here we have, is the one always, yes, numerical. There are numerical variables that are equally spaced. For instance, points scored in a game. You can't score 2.5 points in a game. You either have 2 points or 3 points, but you can't score 2.5. And so we're talking about numerical intervals that are equally spaced. In the case of scoring points in a game, it's usually one per apart. 1 point, 2 points, 3 points. And I guess I'm thinking basketball in this term, because you can score a free throw and get 1 point. You can score a basket and get 2. You can even score from 3-point range and get a 3 point. And then if you start talking about, how many points did this player score? Again, they're not going to, they didn't score 23.5 points in this game. There are some places where decimals and fractions are just not appropriate. And so these are numerical variables. They're expressed as numbers, but there's not really any room for numbers or fractions or decimals. There are other places. Yeah. With these next three, this is where we get to the quantitative. Don't be confused with the qualitative, but these are the quantitative. Quantity, right? These are data points that can be averaged, like ages. You have an average age, or how many dollars does a person make? Those can be averaged. Now, we kind of talked a little bit earlier about numerical variables. There is a similar concept called discrete variables. Matter of fact, there's an entire math course on discrete math, because to be honest with you, it deals with real numbers in real life. There was the joke for so many years that the average family has 2.5 children. How do you have a 0.5 child? You know, it just doesn't happen that way. You either have two children or three children. And discrete deals. Well, one of my favorite topics in discrete math was when I taught it as a course was apportionment was the fancy term. The idea goes something like this. Let's say that I'm pulling numbers out of the hat here because I don't remember off the top of my head. But let's say that well, I'm going to pick on Mississippi and Alabama because they're close, but they're just far enough away to where we don't really know. When the founding fathers created this country, they said, all right, each state is going to have two senators. And so we'll have 100 people in the Senate. But the House of Representatives is going to be based on population. And so bigger states like California and Texas are going to have more representatives in the House than somebody like Delaware or Rhode Island. And so the question is that when you start crunching the numbers and you start averaging, what the latest, 2020 census showed, how many seats should Mississippi have and how many seats should Alabama have? Well, what do you do when you crunch the numbers and Mississippi should get 10.5 and Alabama should get 11.5, based on their average population, whatever. You can't have half a seat in the House. And so the question is, between the two states, that's one seat that's up for grabs. How do you say whether Alabama gets that extra seat or Mississippi does? Oh, there's going to be a fight over that. So, discrete is all about how do I take this kind of a situation and create a fair and equitable way of seating the right number of people for Mississippi and Alabama, and such that they can't argue with the fairness. Now somebody's going to lose a seat. Somebody's not going to be happy, but as it turned out, founding fathers came out with no less than four different methods of fairness. And so they look at all four when they do. Anyway, all right. Variables, data points which can take on any value. That would be continual variable. You can have a length that is 1 meter or 1.1 meter or 1.11 meters. You can keep going with the decimals all you want to. But this is the place where decimals and fractions live and continuous variables. Okay? Yeah. Let's move on to the displays. There are numerical displays. It's really the numbers that take the center stage. And there's graphical displays, where you're really talking more about graphs, like bar charts and segment bar charts. And we'll come on. We'll talk about that in just a second. But this is a blast from the past. Measures of central tendency. Oh, I'd like to think that that is a familiar phrase. Measures of central tendency. That is what we call mean and median. Yes, we're going to come back to those with a vengeance. I don't know about you, but as I walk through the different kinds of statistical problems with these, and they would ask you, check the mean, check the median, check the mode, which one tells you the best answer for where is my central tendency? Who's the middle of the group? Who's the average guy in this group? And I never really saw that mode had much of a use. That's just me. Mean and median were the ones that people usually looked at. But we will continue on. All right, we have bar graph. Now the thing about the bar is that when you look down at the x-axis, these are non-numerical categories. Classroom 5, classroom 6, those actually aren't really supposed to be numbers as much as they are like, Mr. G's class, Mr. B's class, Mr. H's class, that kind of class. This would also be the kind of bar graph where you would report things like how many people have blue eyes, how many people have brown eyes. This is where you would create a graph like that, because the categories at the bottom are not numbers; they're things. They're non-numerical categories. That's what makes a bar graph a bar graph. All right, and there's also a space in between. You'll notice the histogram, there is no space between the bars. And that's because each bar represents an interval, like from 0 to 5, or 5 to 10, or 10 to 15. Now, a technical term here is that sometimes they'll call those bins, like the 0 to 5 bin, 5 to 10 bin. But this is what a histogram. Now, the problem with this is that if somebody wants to ask, so where's the median? Give me a number for the median. Well, I can't give you a number for the histogram. I can tell you what bin it falls in, but I can't give you an exact number, because all this is telling us is that there are 5 students between 10 and 15. There are 5 students between 15 and 20. I could figure out where the median would fall, and I could even try and calculate an average of sorts, but I'm only going to get close. I'm not going to get an exact answer. Or histograms sometimes have disadvantages. All right, a couple of more terms. The frequency is how often a data value lands in that data set. How many times it lands in the bin, frequency, how many brown eyes does it have, blue eyes does it have. Another term with it is relative, which means that you are, does is the proportion at which the category occurs. So that would be like saying, half of all of the people we, checked with had brown eyes. That's like expressing it like a fraction or a decimal or a percentage. 50% of all the people we interviewed had brown eyes. That's a relative frequency. Now, this is something that has become more and more useful in the last several years. The segmented bar graph. And the thing is that each bar adds up to 100%. But you can tell by the blue and by the yellow which, percentages. For instance, if we see that blue has a cell phone, we can measure that, maybe about 40% of 10 to 12-year-olds have a cell phone, whereas you would say 60% do not. And that's where the segment, the one place that I see this happening a lot in graphs is when you do the surveys that say you either like it or you dislike it. They usually come in 5 categories, that you either strongly disagree or no, I don't care, I don't know, or I agree, or I strongly agree. And so those are usually the 5 categories, and it's kind of, I want to say it's the Likert scale. That's somebody's last name, Likert, Likert. And I see a lot of responses with this kind of segmented bar graph response, because it shows you what all 100% said, and just shows you how it was split up. Ah, yes, good old-fashioned dot plot. See that in a little bit. And this is the last one. Now, this is the proverbial box and whiskers plot. Now, the thing was that to create a box and whiskers plot, you had to line up all of your data from lowest to highest, and then you had to cut it in half, Q2. And then you had to cut it in half again, that's Q1 over here and Q3 over here. And those numbers would show up here on your box and whiskers. It would be the low number, it would be the high number. And down here is some sort of scale, gives you a sense of, how large or small this thing is. Now, I do know that in 6A's worksheet, I had originally asked you to do a box and whiskers. As I've looked at it, I realized that the data that I've asked you to look at, I am asking a beast of a questions. I'll skip it for 6A, but I'm pretty sure we're going to be coming back to this box and whiskers plots. Is a fairly easy way of, looking at the numbers and telling, because this box in the middle, that's where the important stuff. That is the middle half of your group when you think about it. Because if you had all of these guys lined up here at the top from low to high, and you cut it into quarters, I mean, it's like taking a stick of butter and cutting it in half, and then cutting those halves in half. So you've got 4 pieces of butter now. Well, you've got your data split up into 4 quartiles, is the fancy term here. And Q1 represents where the first quartile is done, and the second quartile and the third quartile. Now, one other thing that gets caught up in this discussion is standard deviation. Now, I do want to make a comment here that the Greek letter sigma, about a population, but the Roman letter S refers to a sample. Now, we talked earlier about population versus sample. So the question is, when you are doing your standard deviation and you're doing your normal distribution, asking myself, was normal distribution supposed to know standard deviation? Right here. The bell-shaped curve, right? Where the hump in the middle represented where the average person is. If you are doing a standard deviation that covers the entire stinking population, then you're going to use the Greek letter sigma. And when you go out from the median and you go out 1 standard deviation or 2 standard deviations, you're going to use 1 sigma or 2 sigma. But if you're only talking about a sample of the population, and you're doing this standard deviation, then you're going to say 1S and 2S. That's a trivial fact to tuck away for future reference. And I don't know why I needed that twice. Now, I'm going to hit the pause button here. I'm at 24 minutes of this video, so I'm going to break it up into 2 videos, and we're going to come back and look at CODAP. And we're going to do example 1, which is basically getting to know CODAP, and then example 2 is going to be looking at the roller coaster data set and answering some questions on that. And we're going to see some really, I think you'll like what's going on with CODAP. We'll pause here.